Hello, my name is Jeremiah Pitts, and welcome to my showcase of my hackathon project, DevTect. I'm here to tackle one of the growing threats to our health and the environment, microplastics. I'll walk through the problem, show some eye-opening data, and present my AI-powered solution. Microplastics are tiny plastic particles that come from larger plastic debris breaking down over time. They're so tiny that they can slip through many filtration systems and end up everywhere. Recent studies have detected microplastics in human blood cells, our tissues, and many other locations, contributing to possible reproductive and other types of harm. Research is ongoing, and scientists wonder if these will disrupt hormones, carry toxic chemicals, destroy ecosystems, and it's already been observed. So, microplastics affect the environment. It spreads when marine life ingests these particles, and it ends up moving up the food chain when these aren't directly cleaned out. Now, ecosystems are affected because microplastics can affect fish reproduction, coral reef health, and the overall balance of the ecosystem and the environment. And on land, it can contaminate soil, affecting crop growth and potentially entering our food supply. So, now that I've talked about the problem, how about a solution? This is a solution. DevTect, my project, has many different features, including a node graph showcasing the sheer scale of these to a solution that I will present here shortly. So here's my logo, and going on the features. There's an interactive heat map, monthly distributions, 3D visualizations, and AI predictions. And here's just a short timeline of the spread of microplastics and just the distribution in a heat map form. So if we start, here's January, going on to February, there's more debris settling down near Turkey and over by the UK, which is some very shocking data, which I'll get to in a bit, why it's so shocking. So this is a level 3 microplastic heat map. This is basically just the concentration found generally for microplastics. This here, it's over 3 million. So these distributions are quite large. This is a node graph that I've created using Three.js. So while this may look like a bunch of dots scattered everywhere, this is a 3D visualization of our microplastic distribution. So you can take this and you can move it around. It's all a 3D model rendered in the browser. So this really draws awareness to how big of an issue this is. Especially when you consider that it's not just one microplastic represented by these beads, but if you look here, this is 36,000 pieces. But if I hit group by country here, it kind of shows the distribution of how many microplastics there are per country. Now, if we click on one of these, it sort of explodes into an array of the actual microplastics for that country. Now, this here, based upon my map, shows different mitigation strategies. So let's say if there's river interceptors, we can see the different changes on the distributions. And don't let the colors fool you. Technically, the distributions are formulated by averages. So even if it's going down globally, worldwide, you may just see the same colors, but you can hover over it and see the exact amount of pieces and concentration. And then going on to AI predictions. So if you type in a set of coordinates here, let's say 25 and 61, it shows and this is trained via neural network, it shows a prediction of how many microplastics we want to be in that area. So this is very helpful, especially when it comes to my main product, the yearly heat map. So here we select a year and a time increment and what kind of reduction strategy we're using. So right here, this is open ocean skimming, and it shows the predicted reduction and growth in microplastics in certain areas. So here I believe it grows, and then here I believe it reduces because it's over time. These areas will continue to grow, but if we reduce them in these areas, then there's a lot less overall. So it just shows us that we can do a lot to combat this issue. And it really is an issue of both legislation and people stepping up to take a stand against microplastics. So in conclusion, microplastics may be a hidden threat, but with proper data, AI modeling, collective action, we can tackle it before it's too late. So thank you for exploring this project with me. I spent a lot of time on it, and I really hope for a better future for all of us. Thank you.